not you guys, but who can tell me what science is? If you were here last night, don't cheat. Because you already know the answer, or like one of the answers. Who can tell me about science? You were here last night. Yeah, no.
I came late, so it doesn't count.
Okay.
It's observable.
It is observable.
It's repeatable.
It's repeatable. It's testable. Testable is good, yeah. Yeah. Find what? Yes, go. Oh, you need the microphone.
She wants
Why did you have water? What?
You add water and then it makes it explode.
That is science.
Sounds like potassium.
So he's more into experimentation is what he's saying. So science does involve experimentation, right? Frequently involves experimentation. It is objective. So what does that mean, objective?
It's an object.
That's a good answer, Luke.
That is a good answer. It's objective. The opposite of objective is subjective. That does not help Luke at all. He's looking at me like I'm just speaking thing on, so sorry. So subjective, I'm the subject. I use my eyes. If I see it and I experience it, that's subjective. Okay? Objective is I see it, he sees it, she sees it, we see it. It is objective, right? It doesn't, I'm not putting my feelings on it, I'm not interpreting it, it is objective. Everybody knows what repeatable is, right? Yes, because it happens over. I can ask the question again. They are not laughing at me. It wasn't that funny, but. So everybody knows what repeatable is, right?
Yes.
Yes. Good answer, Nicole.
So objective, observable, and repeatable, and that is science. If it is not objective, observable, and repeatable, then it is not science. Isn't that so easy? Yes, it is. So that is why we're here tonight for the Jacksonville Science Symposium. I got tired of all the not science and being yelled at for all the not science. So I don't want to hear all the not science. I just want to know the facts. Just tell me stuff. I already have a belief system and facts fit into it. So all you have to do is tell me the factual information. So that's why we're here with the Jacksonville Science Symposium. Now tonight we have dinosaurs.
Woo!
With the DiPietro brothers.
We're not dinosaurs, but
I'm older than they are, so there's that. Oh, they're like, no. So Aaron and Nathan DiPietro, now I'm going to read the intro. Are brothers, petroleum chemical industry specialists, and fellow science speakers. They have each earned a B.S.B.A. from Thomas Edison State University. For nearly a decade, they have conducted independent research and given numerous presentations on scientific topics. They firmly believe that science should be understandable, applicable, and engaging. That was it. So now we're going to turn it over to Aaron and Nathan.
well, good evening. How's everyone doing?
Fine.
Look, I know we're talking about a topic of dead animals, but you don't have to be so somber. So how is everyone doing tonight? All right. Now, so we're going to be exploring the topic of dinosaurs, the land that once was.
No, Nathan, to start us off, I've got to ask, what's so amazing about dinosaurs that we're talking about them tonight?
Well, Aaron, dinosaurs are fascinating creatures, as we all know. But it seems that everyone knows something about dinosaurs. Obviously, the information available on this topic is as large as the dinosaurs themselves. But before we dig into some dinosaur details, let's talk a little bit about the science of dinosaurs.
Science simply means knowledge, but in this context, science can refer to two different categories. First, we have observational science. This is the science that uses the scientific method. Dictionary.com defines science this way, quote, systematic knowledge of the physical or material world gained through observation and experimentation, end quote.
So basically we observe something, we try to explain it with a hypothesis, and then do experiments over and over again to see if our hypothesis is correct.
Let's use an example to make this kind of science clear. Baking soda and vinegar mix to form a chemical reaction. We can all observe this reaction and come up with a hypothesis to attempt to explain and figure out what the reaction produces, say water vapor and carbon dioxide. Then we can test that hypothesis to see if we're correct. And finally, if our hypothesis is correct, anyone should be able to do the same test again and again and get the same results. If we come up with a different result, then that probably means that our hypothesis is incorrect or at least needs to be revised. Questioning other people's scientific ideas is necessary because that's how science proceeds and helps us to cure diseases, send man to the moon, and so much more.
However, when it comes to the world of dinosaurs, a different kind of science comes into play. Historical science. You see, we can't put living dinosaurs in a lab. Even if we
could, it probably wouldn't go very well.
Right. Good point. So while we can look at dinosaur fossil remains, we're limited in how much we can actually scientifically know about the dinosaurs because they lived in history, and history cannot be observed or experimented on. So while historical science uses some observational science, history only happens once. Therefore, historical science is more prone to error, and ideas about history need to be examined cautiously.
So let's start with what we know. How do we know about dinosaurs in the first place?
Well, from dinosaur books, of course. Okay. So we know about dinosaurs because we can find their fossils of their bones, their eggs, their skin impressions, and footprints in rocks all over the earth. And from these remains, we can figure out several things about these creatures.
For example, we can look at the sharp teeth of many of the dinosaurs. But with the exception of a few fossils, we don't have any record of what the dinosaurs ate. We may automatically assume that having teeth like this dinosaur means that he was a ferocious meat eater. But that's only a guess that may or may not be true. So observational science shows us that they had sharp teeth, but historical science covers the discussion of what they may or may not have eaten.
Take this modern example here. What do you think that this animal eats? It is pretty ferocious looking, but in reality, this is actually the skull of a giant panda. And according to animals.net, the diet of the panda is 99% bamboo, even though that some people think that their jaw and teeth are considered carnivorous, which basically means that if we were to find their jaw out in the wild somewhere, we might wrongly assume that this creature was a carnivore.
So for most dinosaurs, the only thing we know scientifically about their sharp teeth is, well, they had sharp teeth.
So another interesting fact that we know about dinosaurs is their size. Now when it comes to dinosaurs, we often like to think of huge animals like the monstrous Brachiosaurus that grew to as much as 40 foot tall.
Not to disappoint you, but most dinosaurs were not that large. In fact, the average size of the dinosaurs that we have found are actually only about the size of a cow.
So let's take a simple example to help us better understand how we should investigate dinosaurs using historical science. Let's say we're digging in our yard one day and come across the bones of a long-forgotten elephant alongside an old basketball. What do we actually know about the animal?
Well, we can compare the bones to other living elephants and indeed confirm that yes, this was an elephant. But there's a whole lot we don't know. For instance, do we know how the animal died? Do we know if the elephant had any babies? Do we know if the elephant was bold or timid?
Great points. So I find it kind of humorous when reviewing dinosaur documentaries or movies about them to hear some of the comments that people make, like, oh, they ran at speeds of X miles per hour, or this dinosaur had to be careful because T-Rex was lurking nearby. Well, while this may or may not be based on educated guesses, many people will unfortunately not know to distinguish between what is fact and what is simply artistic license. To go back to the elephant example, for instance, we may think that because we find a basketball near the elephant, that they enjoyed playing a simple game of basketball. But we could be totally wrong.
All that to say, when you see movies of dinosaurs or hear that dinosaurs did this or that, always remember that as scientists, we need to be able to distinguish between what is fact and what is simply a guess. So as we go on through our talk, we'll point out along the way what is known and what is simply an idea or a guess that some people have about dinosaurs. As with most historical science, there are often two or more ways of looking at the same evidence.
Additionally, when we look at fossil bones, our worldview plays a big part in how we understand dinosaurs' place in history.
Okay, first of all, we need to define what a worldview is. A worldview is a person's view of the world.
Not very technical. Defined further, a worldview is our most basic beliefs about reality. These fundamental beliefs become in essence the filter through which we interpret the world around us. How we carry out recreation, business, government, and education are determined by our worldview. Our worldview also guides what we believe about the origin of the universe, morality or lack thereof, the meaning of life, and the reason for death.
And as we will see, our worldview shapes what we believe about dinosaurs. There are in reality two fundamental worldviews, naturalism and supernaturalism. The first seeks to explain everything purely by naturalistic means. Naturalism starts with the idea that everything that exists is purely a part of the material world. Thus, because they believe that there is no divine creator involved, everything must have happened by purely physical processes. On the other hand, the other basic worldview starts with a supernatural creator who has acted to create the world and everything in it.
Now, of course, just like with most issues, there are those who will blend the two main positions, but for our simplicity of our discussion here, they almost will still always boil down to one of these two views. These two starting points are in direct conflict with one another and will impact how you view the world around you.
Our worldview is almost like a pair of glasses. Just as different glasses will cause us to see in a different way, so a different worldview will cause you to understand the world in a different way as well. As we will see, two scientists looking at the same evidence can come to two radically different conclusions because of their starting worldview.
Now, it seems like a lot of people are asking the question of where did dinosaurs go? But I think a more important question is, where did dinosaurs come from in the first place?
Here again, this is another worldview issue. From a purely naturalistic perspective, dinosaurs must have come from another kind of animal that traced its ancestry back to an explosion in the past. However, if you begin with a supernatural worldview, you would likely say these animals were designed by an intelligent creator. Again, as scientists, our duty is to look at the evidence and see which worldview lines up better with that evidence. Here's a diagram from the Chicago Field Museum that is seeking to show visitors where dinosaurs came from.
Looks pretty scientific there.
But watch this.
Whoa! That was cool. What is it?
This is the same diagram again, but this time it has the actual number of fossils of each creature that have been found in the fossil record. Examining the chart closely, we can see that the only fossils we have are those of fully formed animal kinds. We have no fossil evidence that shows that different kinds of dinosaurs evolved from a common ancestor. Thus, when it comes to the diagram, all the lines connecting the different creatures are pure speculation, not scientific fact.
So, now, what the University of Chicago paleontologist Dr. Paul Serrano said in an interview when discussing dinosaurs, quote, "I think researchers and maybe even lay people really felt that we had more ancestors in the fossil record than we actually do. We don't have a lot of ancestors, we have a lot of twigs." Then Johns Hopkins University, we've heard that name a lot, paleontologist Dr. David Weishampel also stated that, quote, "From my reading of the fossil record, no direct ancestors have been discovered for any dinosaur species. Alas, my list of dinosaur ancestors is an empty one."
Observational science today shows us something that may help us to understand the origin of dinosaurs. Animals have a vast amount of information in their DNA, a genetic blueprint for life. This allows each kind of animal to express incredible variety within a given group. At the same time, zoology and biology show us that there are limits to the amount of genetic change possible. We find that no new information can be added naturally to the genetic genome. Each animal only reproduces after its own kind of animal.
One example is the feline grouping of animals, aka cats. We can observe the many different varieties of cats, including lions and tigers, bobcats, and of course the average homeless cat. But all of these, in spite of the incredible variety, all of these belong to the same kind of animal family.
We could even get cool creatures like this one, the liger, which happens when a tiger and a lion breed together. The vast information allowing for the variation in the cat's genes allows this kind of cool combo within the feline kind. But guess what? Because of the genetic limits within DNA, cats only ever produce cats. They never produce tomatoes, spiders, or kangaroos for that matter.
Applying this known science to the dinosaurs, we can see a similar trend. This picture shows various Triceratops-type dinosaurs, but they were all part of the same, probably all part of the same animal family. Even though there's some amazing variety in between all of these, what we know from modern science can show us that these probably were all related and probably could interbreed. So when we group dinosaurs like this, scientists have proposed around 50 to 100 different dinosaur genetic families that would have encompassed the varieties of dinosaurs we know of in the fossil record.
That's neat, but hang on for a minute. Let's go back to a basic question. How do we know dinosaurs existed in the first place? The answer is fossils. A fossil, generally speaking, is the preserved remains of a dead, once living plant or animal. Most of the time, the original animal or plant has decayed away and the bone has been replaced with minerals that take the shape of the organism. All over the world, we find millions of fossils in places as diverse as Alaska, Asia, Australia, and Africa. Why are these remains of millions of dead creatures and plants found all over the world?
Well, this is yet another place where worldview comes into play. We know we have fossils. That's observational science. The question is, how did they form? We have to attempt to answer that question using historical science.
According to some, all the fossil deposits we have in the world took vast periods of time to form. A fossil forms here, a fossil forms there over long periods of time. Here's what one science website said regarding several dinosaur skeletons found in Siberia. The fact that the skeletons were not found intact could indicate that while the dinosaurs were alive, that environment had rivers. Upon the dinosaur's death, the water likely transported the animal, causing portions of the skeleton to disassociate. These particular individuals were likely covered by sediment on the bottom of the river, protecting the carcass from scavengers and allowing imprints to be preserved.
But is this really how fossils form? Is it a calm process by which a river calmly buried these dinosaurs when they died? Let's be scientific here, okay? This calls for a science experiment. Now, later this week, if your parents allow, you could try this science experiment. Find a dead cat in your neighborhood, and once you've stretched it out...
Oh, dude. Since most of these people are not likely to have a dead cat lying around in their neighborhood, if you do end up doing this experiment, you can use your average leftover chicken bones. Your choice, fried, rotisserie, or